This video we are solving mole-mole conversion problems, converting moles of one substance to the moles of another substance. Here is our first problem. How many moles of ammonia are produced when 3.12 moles of nitrogen is consumed? So the first step is you want to write a correct balanced equation. Okay, so once you have a balanced equation, then we are going to move on. So here is the balanced equation. All right, now go back to your problem and determine what is given and what you have to find. It is saying you have to find the moles of ammonia. So this is something you have to find. So that's your question mark here. And what is given is 3.12 moles of nitrogen. You write it here. That's how I want you to solve these problems. So first thing is balanced equation, and then write down what is your known and what is your unknown. Once you have that, then you figure out the mole ratio, the correct conversion fraction, because these mole ratios are the conversion fractions. Why are we using the mole ratios here? Because all stoichiometry calculations involving equations, they use mole ratios. So let's figure it out. And once again, what is a mole ratio? Mole ratios are the ratios of number of moles of any two substances in a balanced equation. Well, how do we figure out what are those two substances we're going to use for the ratio? Depends on the problem. And in this problem, we are going to pick the two substances, ammonia and nitrogen. So how do we even figure out, like, how do we even tell that what's the mole ratio here? We are going to use the coefficients in the front to determine the mole ratio. So again, to determine the mole ratios, you are going to use coefficients in a balanced equation, and that's the reason we start out with a balanced equation. Okay, so to solve this problem, let's work on the equivalent. So 1 mole, here it is 1 mole of nitrogen consumed. Every 1 mole of nitrogen consumed, how many moles of ammonia are produced? 2 moles of ammonia are produced. Okay, so this is the equivalent here, and for this equivalent you can write two fractions. Now which fraction are we going to pick? We can have this one in the numerator, this one in the denominator, or this one in the numerator and this one in the denominator. That will still be conveying the same message. Well, to solve it, let's start out with the given. So what is our given? 3.12 moles of nitrogen. So 3.12 moles of nitrogen is already given in the problem. Now the next step is multiply your given moles by the fraction, the mole ratio. Now when you have to write the mole ratios, just like other conversion factors, because this is a conversion factor as well. So since it is a mole ratio, you're going to pick the fraction in such a way where you have a mole ratio of unknown substances at the top and the known at the bottom. So which one is my unknown substance here? Moles of ammonia, right? And which one is my known? It's given moles of nitrogen. So let's make the fraction from here. 1 mole of nitrogen. Okay, I don't want this in answer, so I'm going to cross this unit out. And the ratio, this one at the bottom and this one at the top. 2 moles of ammonia are produced for every 1 mole of nitrogen consumed. Use the calculator, you're going to get 6.24 moles of ammonia. And this is the correct significant figure. We want to make sure that the significant figures are correct. Now let's start the other problem. Propane gas reacts with the oxygen gas to yield carbon dioxide and water. How many moles of oxygen gas are required to produce 15.4 moles of water? Now again guys, we want to make sure that we know the formula writing, we know how to write a balanced equation, we know like where these, you see for the oxygen, why do you have 2 here? That's because this one is the part of those 7 diatomic molecules. So all that knowledge, even you should know the type of reactions. So once you know the type of, once you can figure out the type of reaction, you can also predict the products and reactants. Well, in these questions, the problems I'm doing here, I have already have the balanced chemical equation for you. So you don't have to worry about all those. But otherwise, you need to have that knowledge. Okay? So let's read the problem. Propane gas reacts with oxygen gas. Yes, this is propane reacting with oxygen gas, and what is it yielding? Carbon dioxide and water. It's a combustion reaction, combustion of hydrocarbons. So once again, we are going to start out with given. Well, what is given here? 15.4 moles of water. So I'm going to write here 15.4 moles. So this you already know. So this is your known, right? Now what do you have to find? How many moles of oxygen gas are required? So this is what you have to find. So question mark, moles of oxygen. So this is your known, all right? And this one unknown. And I'm writing here so that you can set your fraction accordingly. Because for the setting up the fraction, you will have the moles of unknown at the top and moles of known at the bottom. So all right, so let's start with the given. What's given here is 15.4 moles of water. 15.4 moles of water. Going to pick the mole ratio, the fraction. Again, how do we know what mole ratio you're going to pick is? When you have the mole ratio, you write the moles of known substance at the bottom. So which one is our known? This one is our known. It says 15.4 moles of water. So to figure out the mole ratio, we look at the coefficients of the balanced equation. Okay, so I'm going to focus on this. There you go. I want to get rid of moles of water. So moles of water will be going at the bottom. Okay, so for 4 moles of water produced, how many moles of oxygen are used? 5 moles of oxygen. This is our mole ratio, and as I said, this is actually an equivalent, and that's how we got the mole ratio. Now you solve it, do the math, you're going to get 19.25. Then it is 1, 2, 3 sig fix, so write here 19.3 moles. Don't forget to write the unit, and don't forget to write the substance. This is important, unit and the substance both. So correct sig fix, unit and the substance. So what does this show? This shows that 19.3 moles of oxygen is needed to produce 15.4 moles of water in this combustion reaction of propane. Now here is your turn. So it's the same equation and I'm giving you answer. I would like you to pause the video and please try on your own. So propane burns in excess of oxygen to produce carbon dioxide and water. How many moles of each of carbon dioxide and water are produced? So you have to find the moles of carbon dioxide and you have to find the moles of water. So this has two parts in this question. Yeah. And what you're going to do, guys? Remember, you have to have a balanced equation first, and after the balanced equation, you want to identify your knowns and unknowns. So what is given to me here? It says 3.85 moles of propane. So write here 3.85 moles. All right, so this is given. Okay, and two parts are, you have to figure out the moles of carbon dioxide. So this one, and you also have to figure out the moles of water. Here you go. So these are the question mark, both of these moles. Moles for carbon dioxide and moles of water. So it's very important that you read the problem slowly, read it carefully, read it again. Alright, so we are going to use the equivalent just like we did before. So from this equation, let's first figure out the moles of carbon dioxide. So for moles of carbon dioxide and the moles of propane used, moles of propane used, we are going to make an equivalent fraction first for the propane, this is propane, and the carbon dioxide. So for 1 mole of propane used, how many moles of carbon dioxide are produced? 3 moles of carbon dioxide. Or you could say for 3 moles of carbon dioxide produced, 1 mole of propane is consumed or used. Well, that's for the relation, showing the relation between carbon dioxide and propane. How about for water and propane? So for propane and water, this is 1 mole of propane consumed For every 1 mole of propane consumed, 4 moles of water are produced. Alright, so we are going to pick these two substances, and then so propane, carbon dioxide first, and then propane and water next. Here you go. Alright, so from each equivalent, from this equivalent, you are able to make these two fractions. From this equivalent, these two fractions. So this is these numbers, these are coming from the coefficients of a balanced equation. Alright, so to figure out the moles of carbon dioxide, you are going to start out with the given. You always start out with the given. Now you are going to multiply with the appropriate mole ratio. Now which one is my appropriate mole ratio? I want to get rid of moles of propane. So I'm going to use this one. Alright. So cancel this. When you solve it, you are going to get 11.55, 11.6. Why am I saying 11.6? Because it is 3 suffix, so you want 3 suffix in your answer. And here you again started with given. Now I want to get rid of moles of propane, so I'm going to use this one, moles of propane at the bottom. So 1 mole of propane used produces 4 moles of water. So cancel this and that. Remember, it's a unit analysis method. You keep cancelling the units, similar units from the numerator and the denominator. When you solve this, you're going to get 15.4 moles of water. Okay. Now, guys, practice is extremely important, so keep practicing as much as you can. I want you to please read these and figure out if they are true or false, these statements. And if you said true, that means you are understanding this concept. Thank you, guys. Thank you for watching.